Okay, so as stated in the previous video, we're going to talk about templates. This is or at least should be, a very short video because the concept's fairly straightforward and there's not a lot of syntax involved in it. Let's just open the file up right now. As I said, super short. When we talked about the STL data structures, I mentioned these angle brackets here, and those are essentially templates going on right there. As I said back then as well, this allows you to point it or pass in any sort of object or primitive type you want into the data structures. However, you can leverage these yourself as well, as we can see here in this little toy example that I created. I created this function called print vector, right? And this is the syntax to essentially say, take in any type, this template angle brackets class T, right? And I'm using this T variable right here in the parameters to the function, right? So this is essentially saying whatever type gets passed into this vector here, this function should work fine for that type as well. Again, we're using this for each syntax, where I'm using the type inference of the auto keyword as well to print out the variable. And then here's the example. I'm using an integer, a vector of integers, a vector of strings, and a vector of floats. And this same function is able to print out all three of these types because I've used this template, the template functionality. So regardless of if it's an integer, whether it's a string, or whether it's a float, this function should still print all these out without any problems. So if we build this, and run it, you can see that we're printing out all three types of these vectors with no compiler errors and nothing bad happening at runtime. So obviously this is like a super powerful bit of syntax that's in the C++ language. So it's, you know, all over the EOS code in one form or another, right? Either they're using the templates here because some other software engineer, they're using a package some other software engineer had designed such that you could use the templates like the STL data structures, or they're actually using them themselves. So I thought I'd throw together a little video just showing how that works. As I said in the STL videos, and now that I've shown you how classes work or even structs work, you could actually, you know, create let's say a vector of cars, something like this, right, would be the syntax. I don't have cars here, right, but let's say we define these cars here. Then you could do, you know, new car 10 v2 10, right? We could just sit and define a bunch of these these would have to be pointers, right, because I'm using the new keyword. So we have pointers to cars in this vector. Well, in fact, if we had the operator overloading for the O stream defined in this car class, we could use the same exact function here, right? Because C++ still has to know, how do I print out a car? So as long as you're covered with that, you could also use this vector and this print vector function in the exact same way to print out the cars like we were doing previously. While I was creating the code for this video, I realized we'd missed one very important topic that EOS uses quite frequently, and that's scoping and namespaces. So I threw together some code for that, and we'll take a look at that in the next video.